Without warning, the mighty Sayano-Shushenskaya Dam erupted into chaos. Turbines shattered, water roared, and workers were swallowed by a nightmare of steel and destruction. A tragedy captured in chilling detail. This is the story of one of history's deadliest hydroelectric disasters. Welcome to Disaster Archives. On August 17, 2009, a catastrophic accident occurred at the Sayano-Shushenskaya hydroelectric power station in Russia, claiming 75 lives and causing extensive damage to the plant. Located on the Yenisei River in southern Siberia, the Sayano-Shushenskaya Dam was the largest hydroelectric power station in Russia and the sixth largest in the world by average power generation. The dam, standing at 242 meters high and 1,066 meters long, played a crucial role in providing electricity to the region. Constructed between 1963 and 1978, the dam was a symbol of Soviet engineering prowess and economic power. It contributed significantly to the local economy, providing jobs and energy to the surrounding areas. At 8:13 a.m., turbine number 2 at the power station failed catastrophically. Here's how it happened. The turbine began to experience severe vibrations due to fatigue damage in its mountings. These vibrations were initially minor, but gradually escalated over time, ultimately leading to the failure of the turbine cover bolts. The cover bolts, essential for the turbine sealed and stable, could not withstand the intense vibrations and pressure. The bolts eventually sheared off, causing the cover to blow off and water to surge into the turbine hall. This unleashed a torrent of water, which resulted in a rapid flood of the hall. The immense pressure from the water quickly destroyed adjacent turbines and caused a partial collapse of the power station's roof. As soon as the failure was detected, emergency protocols were initiated. Workers tried to manually shut down the affected turbines to prevent further damage, but the flooding made it nearly impossible to access key control points. Despite their efforts, the overwhelming force of the water led to widespread destruction of the machinery and structural damage. The plant's control room staff struggled to regain control, attempting to close the intake gates to stop the water flow, but the damage was too extensive. Additionally, there were attempts to use emergency shutdown procedures that involved cutting off the electrical supply to the damaged turbines. But these efforts were thwarted by the rapidly rising water levels and the ensuing mechanical failures. The accident resulted in widespread power outages in the area and left 75 workers dead. The plant's entire power output of 6,400 megawatts was lost. Rescue teams worked tirelessly to save those trapped and recover the bodies of those who perished. The community was left in shock, grappling with the sudden loss of their loved ones. Amidst the chaos, emergency responders faced numerous challenges. The flooded turbine hall and damaged infrastructure made rescue operations extremely difficult. Despite these obstacles, their relentless efforts brought some relief to the grieving families. An official investigation was launched to determine the cause of the disaster. Experts analyzed the wreckage and reviewed maintenance records, uncovering a series of technical and procedural failures. The primary cause of the accident was identified as severe vibrations in turbine number 2, which led to fatigue damage of the turbine mountings and its cover. Over time, these vibrations compromised the integrity of the turbine, culminating in the catastrophic failure. Investigators found that inadequate maintenance and inspection protocols allowed these issues to go undetected for too long. In response to the findings, significant changes were implemented to address the root causes of the accident. New maintenance and inspection protocols were introduced to ensure early detection of similar issues in the future. Engineers and technicians underwent extensive training to familiarize themselves with the new protocols. Additionally, advanced monitoring systems were installed to continuously assess the condition of the turbines and other critical components. The disaster had a lasting impact on the region and the power industry. It took years to restore the plant to full operation, and the incident highlighted the importance of regular maintenance and safety checks. Rebuilding the Sayano-Shushenskaya Dam was a monumental task. Engineers worked tirelessly to reconstruct the damaged infrastructure, implementing numerous safety enhancements along the way. The incident also prompted a nationwide review of safety standards at other hydroelectric plants. The accident also had severe environmental and economic consequences. The sudden loss of power disrupted local industries, and led to significant financial losses. Additionally, the flooding caused damage to the surrounding ecosystems. Efforts to mitigate the environmental damage were immediately put into place. Cleanup operations were launched to address the contamination and restore the local habitats. The economic repercussions were felt for years, as businesses struggled to recover from the power outages and the cost of repairs. For the families and friends of the victims, the tragedy remains a deeply personal loss. Each year, commemorations are held to honor those who lost their lives. The memory of the accident serves as a powerful reminder of the human cost behind industrial progress. Survivors and family members continue to share their stories, emphasizing the importance of safety and vigilance in the workplace. The Sayano-Shushenskaya Dam accident remains a tragic reminder of the potential dangers in the power industry. It underscores the need for vigilance and continuous improvement in safety standards. We remember the 75 lives lost and the lessons learned from this tragedy. Stay safe and stay informed.